All right, welcome. 1 of 1 here. This is, I think, the 4th or 5th time I've tried to record this. All right, so first issue that I ran into was the recording software had to be reinstalled. I recently updated the motherboard on my computer. Yeah, so when I did that, it forgot that it was not registered. So then I had to, so it shut off after like 10 minutes of talking, which is super fun. And yeah, so then I had to re-register it, which is, all fine and dandy, went really smooth. And then I tried to record again and made it through the entire recording, played it, found out that it wasn't actually recording any sound. And so I went through all of my computer settings and, set everything up so it should have been working. And then did this lovely thing to where I did this video again. And lo and behold, the sound still was not working. So I have since tested it a few times, and it appears that it is working now. So fun times. Anyways, back to the video. All right, so the last video that I made, I had a computer / CPU / ALU / whatever the hell you want to call it, and I was putting it all together, and it ran off of command blocks and all that other fun stuff, and I had like a glass like viewing platform, and it was super cool. And yeah, and then 1.13 came around and basically screwed up all of my command blocks. And seeing as how I had something like 500 at least, I didn't want to go and redo all of them, so I just deleted the world. This was quite a few months ago, I should say. And I've since I watched a few videos on YouTube, got inspired again, and I wanted to rebuild it, only to find out that I had forgotten that I deleted it. So then I had to remake it, and then I figured if I was going to remake it, I was going to make it better. So differences here. I mean, it's still basically the same. You could have seen it better from up above, but we have our main bus going around the edge here. That right there is our memory, 64 bytes worth, and this is our addressing for the memory, also 64 bytes worth, because of course. And then this is a register, this is a register, and this is a register. And then each of these are each of the control lines, which are going to be powered by this thing over here, which the video is entirely about, but I figured I'd just explain this real quick. So as you can see, you see very little command blocks throughout all of this, and that's because most of them are underneath everything. You kind of saw it a little bit over there, but what I want this to look like is an actual circuit board, to where like when this is running through a program, you can actually see where the signals are going, what they go through, how things change, and all that other fun stuff. So just to kind of show you real quick. All right. So we're gonna load up the number 3. Okay, so that's our least significant bit, our most significant bit. So that's a 1 and then 2. So that's 2 and 1 make 3. Basic binary stuff. Okay. So we have this guy over here. Now this changes it from being like a space between each of the lines to putting the lines right next to each other. And then this is the same thing, it's just that this is acting as a register for the addressing. So you click that little button right there, and it'll take this right here and shoves it over into there, which will then move this little indicator over to here. And as long as I'm talking about it, might as well do it. You like that? I'm like still flying. I'm like right on top of everything. That was pretty good. All right, so then this changes this over here. It squeezes it down. So instead of being 15 blocks wide, it's only 8 blocks wide. And you can see that the indicator moved over here. So any of these options, so like this one right here, is to write data. Yeah, so it'll take whatever's on here and load it up into here, which is the memory. And then on the other side, I've got the read, which will take whatever's in memory and spit it out onto the bus. Okay, so that being a register, if I turn this off, that will continue to stay in there, which is what we want. So now we have 0 on the bus, and we still have this over there. It's still, whatever. So now we're gonna set it back. that. There we go. That sets it back to 0, moves the indicator over. Super fun, right? Oh, and another thing, I redid this stuff so that way when there is in fact data stored in here, you'll actually be able to see the data up on top. So these blocks right here are actually the data storage blocks. All right, and then I don't know if you saw or not, but this is very, very fast. So in order to get to this little arch right here, the small one, not these other ones, but this little small one, this signal has to go all the way around here, all the way through the memory over there, come over here onto that arch, come through over here, and then kick out over here. So to give you an idea of how fast this is, which is also why I chose to do this instead of over standard redstone. Oh, I don't have it in there. Sorry, but you can kind of see it. Well, you could kind of see it. I don't know. Okay, so let's try this again. Can I get up higher? Okay, so you can kind of see where that is, right? So click the button, and it's gone. So that has to go a very long distance, and it's pretty fast. All right, so as you know, with the last video, we need kind of like a control center / brain for the processor, so it knows, you know, when to go through each of the different memory locations and do the different options and all this other fun stuff here. So in order to do all of that, you need a binary counter. Now, because the command blocks were changed in 1.13, this also had to change. Now, the reason why I'm making this video is because this right here took me three days to figure out. Well, not like all of it, but just to figure out how to get everything to work so we would, whatever, 3 days. So this is just a little timer. And then, okay, so this just makes this little guy turn on. So that's what this one is doing. It turns that to redstone, and then underneath it changes it back to yellow concrete, and that's the same for all of these. So as this one turns on, the one below it will turn it back to yellow concrete, and that's how we get the set and reset. Right. Okay, so the way that I had this before, as far as all of the coding goes, instead of having test for block commands now, we have an execute command. And we can also execute if, which is actually quite useful. So what I was doing before is this would check. So this is like what causes this to activate, and it activates both this block and that block. So what I was doing before is this one would check the block above. So like that one, for example, to see if it was either redstone or yellow concrete. So like this one would check for redstone, this one would check for yellow concrete. And then if one of these passed, then what it would do, so it's execute if block location blah 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 is redstone, run, set block to whatever the opposite of what it was checking was going to be. And then this one would do the opposite. So if this is checking for redstone and setting yellow concrete, this one would check for yellow concrete and set redstone. Pretty simple. All right, so the issue that I was running into, and I don't know if this is like a carryover from like the way that the command blocks used to be, but when you're doing this, one block and everything that's chained to it will run first, and then it will run the next one. So these don't run at the same time, which caused a lot of issues and a lot of headaches, which is why it took me 3 days to figure this crap out. So what would happen is this would turn on, it would detect a yellow concrete, it would set it to redstone, so that would be this one all done, and then it would move on to this one, it would detect yellow concrete, or redstone I should say, it would detect redstone, which this one just set, and then this would set it back to yellow concrete. So what you end up doing is visibly you don't see any change in the block, but if you throw a lantern up on top of it, for example, alright, so we put that on there, right? So then what you would do is like this block wouldn't appear to change, but you would get a pulse and light, which means that it is changing, but then it's changing right back right away. So I had to figure out how to get around that. And so I'm using this block as kind of like a proxy block. Now what I mean by that is that this one is checking for yellow concrete. If it detects it, it'll set this block to a redstone. This one is checking for redstone, so when this gets triggered through, if this is also redstone, it checks through this, changes this to redstone, which then, you know, powers the rest of this stuff. So in doing this, I got this to check and come up with a result, this to check and come up with a result, and in this way, only one of these will actually work at a time. As you can kind of see, it goes from this one to this one to this one to this one, based on whatever this block is, which is what I wanted all along. So after that point, this block here would then set this to whatever the opposite of this was checking. So that's just set block, whatever, 1 above, 3 over, to change to redstone block. And then because this one would set to redstone, there's nothing really there to set it back. So then what this one would do, running conditionally, so only if this one actually goes, is it would set the block to behind, and it would make it yellow concrete, which basically resets it. And then after that, because this is only working in a single line here, we actually have to get this one to trigger, so that way it runs the next line. And that's done with this one here. So 1 block this way and 5 blocks this way, it sets this block here to a redstone block. Pretty simple. And then kind of the same but opposite. This one is checking for the opposite thing, sets this to redstone if it finds it. This one sets this to the opposite of whatever this one was checking. This one right here resets this, and then this one right here changes that one. So you have to remember that only one of these sides is triggering at any one time. So regardless of if it triggers one way or the other way, this one needs to you know, trigger, right? So that's why this block and this block both change this block here. All right. Now, if you're doing a binary counter, you can't just look at this block. The only reason why these ones are looking at only this block is because this is like the starter one. So this wouldn't even be a bit. This would be the first bit, second bit, third bit, fourth bit, all the way through. All right. So, so for this one here, we want this only to change if this block is yellow concrete. So with this one, we have 2 nested execute commands here. So if this block over here and above is so we go back this way, and then up 1. So it's checking the block before it. If this is yellow concrete, because that's the only time that you would actually want to change this one, is if this one goes back to a 0. Because like if you're counting, you have 0, 1, you know, 1, 0, and so on and so forth. Right. So that is checking for that one, and then it's also checking for this block here to see, you know, what block it's set at, so we can set the opposite one. And then once that happens, everything else basically runs the same as what this one is. So the only difference between this command here and this command here is this one is a single execute, whereas this one is 2 executes. This one is checking only 1 block. This one is checking the block before and the block at the same level. And then as we fill this out, each of these are just a repetition. Now for this block right here, because we don't need to set this block here to anything, we actually don't need those command blocks. So this is just kind of repeated. You can kind of see, it's actually kind of fun to look at it like this, because then you can see each of the different, you know, triggers and how it all works, which is kind of fun. So like this one will do a bunch over here, and then the last one sets this one. So I don't know. I think it's cool. Right. So the purpose behind this, I don't know if I've covered this or not, is if you have a program loaded into memory, you have a start point, and then at that point you're going to pull whatever's out of memory and then execute whatever that command is, and then you need to move to the next memory one, which is, if you're running on binary, you need to increment it by 1. So that's what this does. And then the reason why I have this one kind of be like a non-bit block is because I want to make sure that there's time in between when this one triggers and when it turns off. So the time it takes to change this one is twice what it takes this one. So this just gives me more time. Depending on how fast everything runs, I might not need that, but I think I will just for clarity's sake. So like when this is running and you're seeing like all the different, you know, things turn on and off, and it's going to different places, and things are being set and things are being added or multiplied or divided or whatever. I just want to be able to have this be slow enough that you can actually kind of keep track of where everything is going. So that's why that's a non-bit block. All right. So with that being said, certain types of code require you to jump forward in the memory. So like if we're on, memory 16 or whatever, and we need to look at a value that's stored in memory 32, we need to be able to find a way to change this to whatever the one we have to go to is, and then run incrementally from there to finish off whatever that section of code is. At the end of that, it'll tell it to go, back to where it was. So we need to be able to not only push data onto this, but also pull data off of this to store. And so the actual binary counting part is just one part of this whole thing. I still need to do the pushing and the pulling from, and then I need to make up everything else. So like these are the, I don't know what you call these things, command lines? Control lines, maybe? Control lines. So like each of these lines will do like a specific thing. So like if you look at this one, this line here will write to memory. This line here will load a memory address to the addressing. So load a memory address. So yeah, anyways, this one right here will read from memory. So this one here actually runs all the way over here and it goes up that way. Excuse me a minute. Throat's getting a little dry. Talking too much. Right. So you can kind of see it here. Goes this way, goes under all of these, goes up, and then back this way, back to the memory. So this one reads, this one writes. Oh, sorry, this one writes, this one reads. And then, so like this line here, I don't have a sign for it yet. But if this is the A register, this one will write to the A register. This one will read from the A register. Write to B, read from B, write to C, read from C. And so each of these little things that are going to be in here, each have to have a control line. Now, what all gets, activated is dependent upon however I set up the actual, the machine code. I mean, it's not quite binary. It's a bit more, it's like a step up from binary. And that's just like stored things. So like if you want to do this action here, let's say, move data from memory to register A. Well, first you need to, if provided that the memory is already addressed, you need to read from memory, which then loads it onto the bus. And then the next step on that, this is all part of the same command, would be to write this to register A. And then, so that would have that all stored in there. And then the third one would be to clear the bus. So that way, if you put something else onto the bus, it's not going to interfere with anything. So that's 3 different actions that are going to be wrapped up into one code. And that code will have a single byte address or byte, whatever, to describe it or whatever. So like if I store, let's say that it's, 47. Like if you go to, if you put in 47, then, hold on. With 8 bits, I can get 264. So let's say that it's like 263, right? So if you load up 263, it knows to go into the brains, which will be what this is. And then it'll find that particular address, and then it'll have that line of different things you have to do. So then it'll run that, it'll run that, it'll run the next one. And then all of that has to happen between each increment of this, right? So I think I'm going to have either 4 or 5 actions per incrementation. So, I mean, not all of these things are going to use all 5 of the actions, but oh man, I know that I'm getting into really complicated stuff, and I've been talking for a while, and my throat's kind of dry. So I think I'm going to call it for here. Mostly I just wanted to show this binary counter, show that it can be done with command blocks in 1.13. It took a long time for me to figure this out. All right, so I just wanted to share the knowledge. Hope you enjoyed. I'm not going to ask you to like or subscribe because I'm not in it for the money. I'm just trying to show you guys some interesting stuff. If you like it, you can use it. If you make a video about it, they'll, say, hey, I got this from, 0, 1 of 1. Just kind of give me a little props. But yeah, so that's pretty much it. I don't know when my next video is going to be. Look, you're going to see it all change. More. That's cool. Okay. Anyways, I don't know when my next video is going to be. Just stay tuned. And yeah, I'll see you later.